Hey everybody, welcome to InterviewBlog. In this video, we will be covering the binary search algorithm. So the question gives us an array of integers and a target value, and it asks us to write a function to determine whether the target element is present in the given input array or not. If the target is present in the given input array, then we have to return true, and if it is not present, we have to return false. So before moving forward, I just wanted to make a point here. The binary search algorithm is a very important algorithm. We may have used it several times in our real life. So let me explain this algorithm with a real life scenario. So let's say you are the representative of your class and you have got all the answer scripts of the students present in the class. Now the register number of the first person in the class begins with 301 and the register number of the last person ends with 400. Now the lecturer wants you to pick the answer script of the student whose register number is 375. So in this case, to pick this answer script, what you will do is you will first split this bundle by half. Now let us assume these answer scripts are arranged roll number wise in ascending order. We can see that the answer script of the student with the register number 375 will never be in this bundle, since in this bundle, we will have the answer scripts of the students from 301 to 350. And in this bundle, we will have the answer scripts of the students 351 to 400. Now, I'll eliminate this bundle and I will now split this bundle by half. After splitting this bundle by half, I will have 351 to 375 in one bundle and 376 to 400 in another bundle. Now I'll be eliminating this bundle and I can easily find that 375 is the last answer script in this bundle, and hence I will return this answer script to my teacher. So this is how a binary search algorithm works. So let us now try to implement this in terms of code. So to solve this problem, I'll be using two pointers, that is the left and right pointers. And initially, my left pointer would point to the 0th index of the given input array, and my right pointer would point to the last index of the given input array. So each and every time, I'll be calculating the middle index, where my middle index is equal to my left index plus right index rounded and divided by 2. So now I'll be calculating the middle index. Now my left index is 0 and my right index is 9. And when this is rounded and divided by 2, I'll be getting 4. So my middle index points to the element that is present in the 4th index. So now we will compare the element that is pointed by the middle index with the target element. We can see that the element at the middle index is less than our target element. Hence, we will never find this target element in this part of our array. That is, our target element will never be less than 12. Hence, we can eliminate this part of our array, and we can now say that our left index would be middle index plus 1. So we'll be moving our left index to our middle index plus 1. That is 4 plus 1 will be 5. Now our left pointer will be pointing to the 5th index. So now we will again recalculate our middle index, and our left index is now 5 and our right index is now 9. When it's rounded and divided by 2, we will get 7. So now our middle index points to the 7th index of the given input array. Now we will compare the element that is present in the 7th index, which is 41, to our target value, which is 39. Now we can find that our element in the middle index is greater than the target value, and so we will never find our target in this part of our given input array. Hence, we can eliminate this part. So how to eliminate this part? We will be eliminating that part by saying our right index is now middle index minus 1. So our right pointer will now point to the element at the index 6. Since our middle index is 7, and when we do minus 1 with that 7, we will get 6. Hence, our right pointer will now point to the 6th index of the given input array. So now we will again recalculate our middle index as our left index, which is 5, plus our right index, which is 6, rounded and divided by 2, which will give us 5. So now our middle index will point to the element which is pointed by the left pointer. Now we will compare this 34 with our target value, which is 39. We can find that 34 is less than our target value, and hence we can eliminate this part of our input array. So how do we eliminate? We can eliminate by saying our left index is equal to middle index plus 1. That is, our left index is equal to 5 plus 1, which is 6. So now our left pointer also points to the element that is pointed by the right pointer. So now we can see that our left index and right index points to the same element. Now again we will be recalculating our middle index by saying our left plus right rounded and divided by 2, which will again give me 6. So our middle index will also point to the same element, and we will now be comparing the element that is present in the middle index and our target element. Now we can find that both are equal, and hence we can return true in this stage. So let us now see this example where our target value is not present in the given input array. In this case, our function has to return false. So first, we'll be calculating our middle index as left plus right rounded and divided by 2, which will give us 4. Hence, our middle index will point to this 12. And now we'll compare this 12 to our target value, which is 52. And you can find that 12 is less than 52. Hence, we'll be eliminating this part of our array. So how will we eliminate? We'll be eliminating by saying that our left index is now middle index plus 1. That is 4 plus 1, 5. So our left index will now point to the fifth index of our given input array. Now we will again recalculate our middle index as our left index, which is now 5, plus our right index rounded and divided by 2 will give us 7. So now our middle index will point to the element that is present in the 7th index. So now we will compare this 41 to our target value, which is 52. And we can find that 41 is less than 52, and hence we'll be eliminating this part of our array. So how will we eliminate? We'll say that our left index is now equal to our middle index plus 1. That is 7 plus 1, which gives us 8. Our left index will now point to the 8th index of our given input array. Now we will again recalculate our middle index by saying left plus right round and divided by 2. That is 8 plus 9, which is rounded and divided by 2, which will give us 8. So our middle index will point to the 8th index of our given input array. And now we'll compare the element at the 8th index, which is 49, to our target value, which is 52. And we can find that 49 is less than 52, and hence we will say that left index is equal to middle index plus 1. That is, we will eliminate this part of our input array. So now our left index will now point to the 9th index of our given input array. So again, we will be recalculating our middle index as left plus right round and divided by 2. That is 9 plus 9 round and divided by 2 will give us 9. That is, our middle index will now also point to the 9th index of the given input array. Now we'll compare the element that is present in the 9th index to our target element. So now we can see that 50 is less than 52, and hence we will be eliminating this part of our array by saying left is equal to middle index plus 1. So 9 plus 1 will now be 10, and our left index will now go past the right index. So when we reach this case where our left index is greater than our right index, it means that the target element, that is 52 in this case, is not present in the given input array. Hence, our function in this stage should return false. So hope you understood the problem. Let us now analyze the time and space complexity of our solution. The time complexity of our solution tends to be big O of log n, where n is the number of integers in the given input array. So why is our time complexity log n? In this scenario, to find this target element, which is 52, first we'll calculate the middle index and compare this element at the middle index with this target value. We can find that this target is now greater than middle index, and hence we will be eliminating this part of our given input array, which means that we are eliminating half of the given input. That is, if the given input is of size n, in this particular iteration, we are eliminating n by 2 of the given input elements. So next we'll be recalculating our middle index, and now our middle index will point to this element 41. Now we'll compare this 41 with our target value, and since our target is greater than this 41, we will now eliminate this part of our given input. That is, in this case, we are eliminating half of the given input. Again, in this scenario, we will select this 49 and we will compare this 49 with this 52. And since 52 is greater than 49, we will again eliminate n by 2 of this portion of the given input array. So each and every time, since we are eliminating n by 2 of the given input, our time complexity tends to be big O of log n. The space complexity of our solution tends to be big O of 1. So why is it big O of 1? Because we aren't using any extra space and we are completing the solution using just pointers, and hence our space complexity tends to be big O of 1. So hope you understood the binary search algorithm. Let us now implement this algorithm in code. All right, so we got our binary search function defined, which takes in a sorted array and a target value. So as discussed earlier, I'll be using a left pointer which points to the first index of the given input array, and a right pointer which points to the last index of the given input array. So now we'll be iterating until our left pointer is less than or equal to our right pointer. So whenever our left pointer is less than or equal to our right pointer, we'll be calculating the middle index. And this calculation is our left index plus right index rounded and divided by 2. So now if the element that is present in the middle index is equal to our target element, then we have to return true. Or if the element that is present in the middle index is less than our target value, then in this case, we have to eliminate all the elements that are less than our element that is present in the middle index, including the element that is present in the middle index. So I'll be saying my left pointer is now equal to middle index plus 1. Or if the element that is present in the middle index is greater than our target value, in this case, we'll be eliminating all the elements that are coming after the middle element. So I'll be saying our right index is now middle index minus 1. So this will be our solution. So whenever this condition breaks, it means that our target element is not present in the given input array. And hence, in this case, we have to return false. So this is our binary search algorithm. And this algorithm has a time complexity of big O of log n and a space complexity of big O of 1. And here n refers to the size of the given input array. So why is our time complexity log n? Because in each and every iteration, we are eliminating half of the size of the given input array. Hence, our time complexity tends to be log n. And since we do not use any extra space in our algorithm, our space complexity tends to be big O of 1. So let us now test our solution. Let me just copy our solution. All right, so this is Leetcode problem number 704, which is the binary search algorithm. So this is the same question that we discussed right now. Here the output type differs from what we actually saw. Here they are expecting the index of the target element. In this case, the index of the target element in the given input array is 0, 1, 2, 3, and 4, and hence our output returns 4. So I'll just paste our solution here and modify our solution to return the index of the target element if found. So instead of returning true, I'll be returning the middle index. That is, our middle index will be the index of our target element. And instead of returning false, That is, whenever my target is not present in the array, I have to return -1. So instead of false, I'll be returning -1. Return binary sets of nums, comma, dot. So our solution got accepted. Let us now check our solution by running all the test cases. So yes, our solution has been successfully submitted. Hope you understood the problem. Do subscribe and check out our channel for more videos. Thank you so much.